Hello, everybody. Thank you for joining us today. Give us one more minute. We will let everybody join in, settle down, and we will start exactly at 11:01 Eastern. All right, so let's get started. Thank you for joining us today. Good morning, good afternoon, good evening from whichever part of the world you're joining us from. And I hope in these COVID situations, you and your dear ones are keeping safe. So we will be going through a workshop today, how to deliver next generation customer experience. Speaker today is going to be Stephen Fuller. He's Senior Solutions Engineer at TigerGraph. Before we get into the real work, let me get a little bit of housekeeping items off the screen here. Although your audio is muted, you can ask question anytime using the Q&A tab, which you will find on the Zoom menu. This webinar is being recorded, so yes, it will be emailed to you. All the slide and the exercise work will be emailed to you. And also, if you have any challenges with the Zoom itself, you have to contact the chat organizers. With that, you can see the Q&A button at the bottom, which is pointed on with the red arrow on the screen. And you can always use that to ask the question. We will recommend you to use Q&A so that everybody else can see it and we can respond it, though you can alternatively also ask on chat, but that's the second priority in case your Q&A isn't working. Let me introduce you to our speaker today. It's going to be Stephen Fuller. He is 20+ year veteran in the tech industry. He has 7+ years of Hadoop and big data experience, 10 years of customer analytics experience. He has completed 1 year with TigerGraph, and he has brought in some really impressive customers to our, to our kitty with various different industries from banking, finance to customer analytics and customer success. With all that in mind, I'm going to pass it on to Stephen now and take it away from here. Stephen.
All right. Thank you guys very much. Thank you, Abhi, for getting us started. Glad everyone is able to attend. We're going to spend the next probably 60 to 70 minutes doing a hands-on workshop around next generation customer experience. Just as a high-level agenda, we're going to, one, just kind of set the stage, kind of talk about what next generation customer experience is. I'm going to give you guys a brief demo of this customer experience solution. And then we're going to do some setup for TG Cloud that's going to enable each one of you to kind of walk through some of the hands-on exercises related to customer experience. We're going to spend some time talking about customer experience as a graph model. We're going to talk about how to map and loading data into the TigerGraph graph database. And then we're going to walk through 4 of kind of the primary use cases in customer experience. The first being able to do entity resolution. The second is having the ability to have a 360-degree view of the customer. The third use case is having the ability to do just SQL analytics, aggregations, and types of calculations on top of the graph database. And the fourth use case is, using graph algorithms for things like product recommendations and finding similar customers. And then we'll kind of have a part for summary and next steps. Okay, great. Getting into this, just always good to kind of start off with a definition and description of what customer experience is. It is the concept of, it's the product of all the different interactions between an organization and their customers, potential customers, and longtime customers. It's that summary of the relationship that organizations have with their customers, and it's made up of three main parts. It's made up of the customer journey, meaning the path, the sales cycle, the engagement cycle that customers have with an organization, any types of interactions they have. And in this 21st century, this can be email, phone calls, chat messages, text messages, interactions on social media platforms, um, picking up sentiment and other things from applications like Twitter, and then understanding how to address your customers through a particular channel. What's the best way to serve and deliver? How do people prefer to be handled for support? How they want to be contacted? And then leveraging all of these behaviors to drive customer sales, lifetime value, and reduce churn. So this is kind of what we kind of look up as customer experience. As a whole, customer experience can also be kind of described as this. On the bottom, you have several phases of a customer journey. Depending on the industry or the line of business you're in, some of these phases may change, but at a macro level, most customer journeys will start at marketing. You get to the point where you do sales, you do fulfillment, you do some type of service. Then organizationally, you're going to go through and do some kind of insights and analytics. You're going to have programs that focus on retention. And then really advanced organizations have programs that focus on turning your customers into advocates. So this is kind of looking at that customer journey or that pipeline that most people have. On top of that, you have this, this digital experience operating model to where you're capturing data, understanding interactions from multiple different contact points, having the ability to pick up stuff from mobile apps, wearable devices, online communities, your own particular corporate e-commerce site, support, taking all that information, combining it together, and creating a single omni-channel view of the customer. That's in particular one of the reasons why we believe that any customer experience solution is going to begin with a entity resolution use case. The first objective is to capture that single 360-degree view of the customer. Next, you want to basically have a process that's looking at experience management. This can be marketing, inbound marketing, outbound marketing, digital marketing, offering up white papers, blogs, product reviews. This can be social media marketing, all these different things that are managing that digital experience. How do you engage with your customers? How do you organize your data? How do you segment customers to begin to market to them and figure out what their patterns are? And then realizing the information from that and turning that into a real value exchange that is immediate, interactive, and based upon those consumer preferences. This is what we kind of consider, that next generation customer experience. The good thing is a lot of the technology, a lot of the things that you need to accomplish these tasks are part of the TigerGraph platform. And so that's what we're going to kind of spend some time with addressing today. So before we get into the hands-on workshop, we need to spend some time allowing everyone to get a workshop environment built and set up and going in our TigerGraph Cloud environment. So at this moment, if you could, we're going to have you go through and register for an account at TigerGraph Cloud. The URL is on your screen, http://tgcloud.io. Registering for an account and setting up an account should take about 3 or 4 minutes. You should be able to sign up for a free account. At this time, it should not request for a credit card or anything. So we're going to take probably a 2-minute break, give you the ability to go set up and register and create a TigerGraph Cloud account. While you are doing that, I will try to lightly and gingerly kind of give you an overview of what tgcloud.io is. tgcloud.io is our managed service software as a service solution. It is a completely pay-as-you-go managed service solution for TigerGraph that does three main things. One, it gives you a very flexible and optimized environment to do graph analytics and graph algorithms. The second thing is we offer up about 20 different starter kits that will accelerate your ability to understand and get started and drive business value from graph analytics. And three, it offers up a platform for investigation, discovery, proof of concepts, and production environments that support whatever your graph analytical needs are. We make it really simple and easy to get started, and to help people get on board and get ramped up into speed. We give everyone a free account. That account gives you access to the platform, I believe, for 7 days. There are a couple of rules that are associated with it. Because it's free, if a node has been inactive for 2 hours or more, we will shut it down. And then if a platform hasn't been used for a week or more, we'll actually go through and clean it up and delete it. So there are some rules in the free play freemium model that will kind of help you to understand that. While you guys are doing that, I'll also quickly kind of just give you a view into my TigerGraph Cloud portal. The first thing you'll get is a dashboard that shows your usage and all the different things that you leverage. And it actually gives you a historical view of your monthly usage. In December and January, you can tell I was quite busy. But in the dashboard, it's going to give you a holistic view of what's happening, the number of solutions you have up and running, what the current balance is, and if you have any unused credits. This becomes a very good way for people to get started with TigerGraph. We give you the option of pre-purchasing credits. So you can go through and buy $20,000, $50,000 worth of credits and do whatever activities you need to do, and do it in a very cost-effective manner. The second thing we do is we give you the ability to go through and create starter kit solutions. So if you click on the right-hand top button where the blue button says create solution, you will be given a wizard to go through and launch a solution. The first step is to pick your version of TigerGraph. The second step is to pick one of our about 20 different starter kits. These things range from fraud and money laundering to graph algorithms for understanding shortest path, healthcare referral networks, in-database machine learning, data lineage, cybersecurity. We have given what we call starter packs to one, help you get started, help you get understanding of the power and the value that these graph use cases provide, and help with training and educational purposes. Okay, we're going to give you guys about another minute to get your cloud instance set up. And if anybody has any questions or concerns, you can either raise your hand, hit the chat window, or ask a question in the Q&A board. Okay, so at this point, I'm going to continue on. Hopefully you have created or you are very close to creating your TigerGraph cloud.io account. And if you have gotten into that account, I'm going to walk you through launching a blank instance that we're going to use for today's workshop. There is a question in the Q&A session. Is there a lab guide or another document that we can use to work off instead of or along with the Zoom? We have a guide that we sent to you after the session is over. So that'll actually give you the ability to not only work along with us now, but if you want to do this at a later date, we'll provide all the instructions for that as not. There was also a question in the Q&A about what are some of the big differences between TigerGraph and Neo4j. Didn't really spend a lot of time giving kind of a architectural background of TigerGraph. The key difference to walk away from is TigerGraph is what we call a big data graph database. We have a distributed, massively parallel processing graph database that allows you to scale to billions of rows, hundreds of terabytes. Fundamentally, Neo4j will begin to have some architectural concerns when they get ready to scale past 4 or 5 nodes. What that means is once you get a graph database that's 2 or 3 terabytes in size, NeoView will have challenges. And that's actually where we begin to look much better than them. The other difference is we have a language called GSQL that's called GraphSQL that is a Turing complete language that allows you to do graph traversal, analytics, graph algorithms, and calculations. That's much more sophisticated and much more capable than some of the things that you would get in other graph languages. There are a whole bunch of other comments, but if you want to get some real understanding between the difference between TigerGraph and Neo4j, basically hit our website. You can go out there and download our product and then do the contact me, and we will have someone reach out to you and set up a session to go through that. Okay, let's push forward. So now we're going to go through the concept of launching your instance. In your graph dashboard, hit the My Solutions tab on the left-hand side, the item that says My Solutions. Now what you're going to do is in the top right-hand corner, you're going to hit the Create Solution button. It's the blue button in the top right-hand corner. This is going to give you a wizard to basically launch a managed service solution with TigerGraph. If you see on the top, there are basically 4 steps: the basic settings, your instance settings, the third step is solution settings, and the 4th step is going to be a confirmation. So in step 1, the first choice we have is to choose which version of TigerGraph you'd like to run. We're going to leave that at version 3.0.6. The next step is to choose a starter kit. There are several to choose from. I highly recommend that after this session, you go through and launch a couple of them and, familiarize yourself with them. However, for this training, we're going to choose the one that says blank V3. So we're just going to create a blank TigerGraph database. After selecting that blank V3, you can scroll down to the bottom of the page and you can hit the orange Next button. That's going to take you into step 2, which says instance settings. The first option there is to select your platform instance. Naturally, you have 3 choices: AWS, Azure, and then shortly we will be having our managed service solution on GCP. In all of these cloud environments, you can manually go through and launch EC2 instances and install TigerGraph through the manual way. All of these instances you can actually purchase and run TigerGraph through their marketplace. This option allows you to launch it in our software as a service environment, but all other options are still available. For today, we will choose AWS, and then for the select instance type, choose the first one, which is TG free. This is going to be the free instance. And like I said, because it's free, we will run some optimization steps behind the scene to make sure nobody leaves rogue instances up for 6 months. The third step is to select your region. Just like what's available to you in AWS, there's several regions. I'll leave mine at Northern Virginia. The fourth option is to choose the disk size. For today's workshop, please leave that at 50 gig. A couple of other options is partition factor and replication factor. And this, we're going to leave this at 1, and it's actually defaulted to that when you're using a free instance. However, this also speaks to TigerGraph's MPP distributed graph database. So if you set the partition factor to 3, that means you're going to have 4 different, if you set it to 3, you're going to have 3 different servers, and then you can set your replication factor to 2. This is how easy it is for us to go set up a distributed graph cluster and define our continuous availability and replication in that. To set that up and configure that in this software as a service environment, you literally just set the number of distributed partitions you want in your graph database. Then you come through and set the number of replication factors you want. So as a brief summary, for the free tier, we chose AWS. We chose the instance type of free. We're going to do it in Northern Virginia, 50 gig disk size, replication and partition factor of 1. Then we can click next. Here, we're going to go through and just start tagging our instance. So you can tag your instance. What I recommend is you put in something that says customer experience workshop, or tag it however you would like. You can set a default initial password. You can change that. However, if you don't change it, the default password is going to be TigerGraph, all lowercase. You can also go through and customize your domain. So I'm going to put my name as the custom domain, and this solution is going to get created. And the domain is going to be stephenfuller.i.tgcloud.io. And then you can put in a description about what is this for. After you've done that, please click next. The final thing is just going to give you a summary of what you are about to launch. The version, the starter kit, what platform you're going to be on. And it's going to give you, if you're in a non-free version, it's going to give you an estimate of what this thing is going to cost you. And then you can click submit. After you click submit, you're going to walk through, it's going to go through and do all of the creation processes to launch this solution. Naturally, it's doing all the things that you understand that's part of cloud orchestration. It's going to go out, launch an EC2 instance, install TigerGraph on top of that, put that out there and make it available. Normally, this process takes 3 to 4 minutes. It's just more a function of, how long it takes to launch and spin up an instance in whichever cloud provider, AWS, Azure, or GCP. A lot of these things are pre-built AMIs that we have, but it's all just runtime that it takes to do this within TigerGraph. Okay, I'm going to take this opportunity, that is as everyone gets their solution launched, I'm going to take this opportunity to give you guys a demonstration of the solution that we're going to build throughout this workshop. So I already have a pre-built solution. My solution is called Customer Experience. What you're looking at now is TigerGraph's Graph Studio. It has two basic functions. One is more of an end user, data engineer, kind of data developer function that allows you to do all of these things like design your graph schema, map and load data, do some graph exploration and traversal, um, write G-SQL queries, and then we also have a no-code graph SQL generation. So this is part of that kind of data engineer, explorer, business analyst interface. We also have an admin interface as well that will give you a review of how many nodes are in a cluster, the number of graphs, and it actually will give you performance metrics for the queries that you're running and all those different things. So for this demo, the first thing I want to do is look at the graph schema that we're going to leverage for doing customer experience. To kind of quickly describe this schema, we have, there is a question in the Q&A that says, how do you load data to ingest data from RDMSs like MySQL or other places like that? I'll answer that question and let me kind of do it a couple ways. Number one, we are currently developing a relational migration tool that will allow you to leverage JDBC and ODBC, connect to a relational database. TigerGraph will inspect that relational database, its schema, primary keys, foreign keys, and it will make a recommendation of what this graph schema should look like. And it will run some jobs to go through and migrate that data over and load the graph database. So that's one option. We also have a way of loading data through our GUI, which we will show you not only in this demo, but in the workshop, you will do some of those things as well. And then we also have a command line tool that leverages G-SQL to load data, just like SQL Loader with Oracle or Copy with MySQL or Microsoft SQL. So there's this simple loader utility that we support. Additionally, we have the ability to pick up data through Spark with a JDBC driver. We also have the ability to pick up data and live streaming data through Kafka queues and Kafka messages. So we support about 6 different ways of data ingest and data loading. There's another question that says, do we not see any pending roles? If you're not getting a list of all your solutions, make sure you do a refresh and then click the create solution at the top, and it should take you into that menu to the wizard that walks you through picking up your starter kits. Okay, so our graph schema is basically a customer related schema. In the middle or the heart of this graph schema is we have profiles. You can call these contacts, you can call them customers. Some people call them persons or people. I call them profiles, mainly because we're getting data from all these disparate sources. I don't know who's a customer, who's not. Some of the information is unbalanced, so we call them profiles. You have their name, date of birth, income, education, marital status. And then we also have another vertex or a vertex that we call customer that we're going to use some basic ETL logic to figure out, hey, here are all my profiles. Let's do entity resolution. Then I'll just create a process that says, let's just identify customers. We could use that as an attribute of this vertex, or we can create a separate vertex. I'm displaying this to give you an understanding of the flexibility and how you can design your graph schema. Each profile is going to have multiple, what I call entity objects. These are things like email, phone number, IP address, and their physical address. To model those, we have different addresses, we have different vertexes for each one of those, and then there's an edge that connects them. We will leverage these entity objects to do our entity resolution use case. We also have a connection between profiles to see who are friends. If we picked up information from social media sites, if we picked up information from connections on Reddit, if we picked up information from any other place, we now know how kind of relationship they have. This edge could contain families. This edge can contain neighbors. This edge can contain coworkers. We're just generically calling it that they're friends. So on the left side of this graph, we have entity objects. One of the things that becomes important about Customer 360 and entity resolution is what source you're getting the data from. And once again, we could have had data source on every object, and we can have it differently. The key thing to remember is in this schema, our edges also have the ability to support attributes. So for each one of these connections, I keep up with the source to where this data element came from. And I want to keep up with the first date I saw it and the last date I saw it. These are just things that become important when you're trying to do an MDM or an entity resolution solution. Different sources are more trustworthy than others. And you want to have sometimes include that in your logic when you're doing entity resolution. On the right-hand side, we begin to look at customer experience interactions. We talked about customer experience as that customer journey and the interactions that consumers have with an organization and have an ability to maintain those. And so naturally now what this model is doing is we're keeping track of all the different interactions. Your interactions with support and the reason you call support. Interactions, through social media, websites, chat, all these things. So any post that you have made or the consumer has made. Same thing with interactions either through chat, support bots, customers, websites, all those different things. And then we also have a vertex for campaigns. This is for outbound and inbound marketing. You will do a marketing message that you create a campaign, and now you want to track if somebody responds to that campaign. And then last but not least, we actually now have orders. Any orders that someone has purchased, the store that they purchased it from, and the products that they purchased when they made that order. Although this visually looks different, it now begins to look very similar to the things that you would do in a relational database. It has the connectivity and connected data that you wouldn't get from a key value store, and things get really cool. Okay, to go through this previous question we asked, there was a question about mapping data. We give you the ability to quickly go through and map data. You can go through and add a data file, select that data file and click add. You can define what that data file looks like, if it has a header, what format it is, the delimiter, the inline character, and if you have any kind of enclosing character. And then we give you the ability to have really simple mapping logic that says, I want to take this incoming source file and I want to map it to a particular vertex or edge. All of this is done visually through the GUI, very simple. We do allow you to have some different kind of light ETL mechanisms in here to where you can do concatenation, you can format dates, things of that nature. The characteristic is anything that you can do in a database loader like Oracle or MySQL, you can do in the TigerGraph loader. We give you the ability to do it visually. Once you've gone through and mapped your data, which we will do in this exercise, you can go through and actually load the data. In the GUI, it'll come through when you hit the load data tab. It will highlight the start loading button as a play button. and you can click that and you'll start loading your data. So now what we're going to do is explore this graph using graph traversal. And so one of the things I want to do is I'm going to start looking at things. So I'm going to tell my Explore graph to go out here and look at stores, and I want to get a random 5 stores. And almost instantaneously, I get the information back for 5 stores. So this store is in Oklahoma City. It is a super center. They also have a salon in it. It's in Chandler. I pick up the lat long and things like that. And now I can begin to traverse this store. I can go through and say, let's traverse this store and see the things in it. Although we visually show the graph quickly, one of the first things you can do is go into a store, and now I see all of the orders that were made at that store, and I see all of the locations that are attracted to that store. That's called graph traversal. All right, I'll give you guys a minute to catch up, and then we'll go on to the second part. Okay, so now what we want to do is we're going to go look at Customer 360. The second use case in a customer experience is to be able to get a 360-degree view of customers. So in the same way we did our graph traversal earlier, we're now going to go through and say, let's look at a random customer. We have Sean Kirby, we have John Jones, and Keith Mullins. I want to now use my graph technology to traverse this customer concept. I can do that by double clicking, and immediately I get a 360-degree view of the customer. Everything that I know about this customer, I have all of their campaigns, their support interactions, their phone number, the purchase orders they've made, the data sources they've come through, IP addresses they've used, and other types of interactions. That's what we call a single hop. I can now hop into their order. And I now, here are the orders they had, here are the products they purchased, here's the store that they purchased it from. I can hop into their campaign. And when I do this, I'll see the other people that were part of that campaign. This is what we affectionately know as graph traversal. The cool part about graph traversal is I begin to traverse this graph database, I see connections show up. So this person, Sean Kirby, and this person, John Jones, they are connected because they came from the same BuzzFeed data source. I can look at another person, and now I have a 360-degree view of this, and they have a couple of different connections because they both have been marketed not only from one different place, but they also have made some kind of interaction on Amazon. This is effectively Customer 360. We're doing it, we're returning the data in sub-seconds and milliseconds. Conversely, on a relational database, irregardless of how much you have, this would be something that would take 3, 4, or 5 minutes. It would involve multiple table joins, sometimes outer joins. It would be a very expensive query to do. We do it basically, it's just a natural fact of what you get from graph traversal. Now what we're going to do is we're going to actually go run some queries. The first thing we want to do in our use case model is we want to do entity resolution. So I want to go create an entity resolution query, and I'll walk through the logic for this. Is I want to go figure out who's the same profile. One of the things we do is as you're writing your queries, we give you a view into the schema. And my logic says, if someone traversed through the graph, go grab all of the connections or the edges that a person has, loop through them, aggregate it, and if someone has the same phone, I'm going to give them a score of 0.3. If they have the same email, I'm going to give them a score of 0.3, same IP address, 0.3, same physical address, 0.3. And I'm going to accumulate a score. If that score is greater than a threshold that I'm going to input into the query, it's going to insert an edge into a edge called same profile. The incoming profile ID plus the profile ID he attached to, and then the score that we've calculated based on those things. There's a question that says, are there built-in fuzzy string matching algorithms? We have the ability to do that. For this demo and this purpose, we're not using fuzzy matching, but it's a very important question in this whole customer experience thing. The benefit of the graph database is I'm now have several other components that contribute to entity resolution other than just doing string matching on their name. We can leverage email address, IP address, a device, a phone number, all these things. And so, so now what that does is it gives you a much better degree of certainty that's above and beyond what you can get into fuzzy matching stuff that's really only associated with the name. And that's why you can kind of calculate the score. We do this several ways. I'm doing it here with just a really simple calculation for demo purposes. You can do it with fuzzy matching. And we actually have a starter kit out here that does the same thing through a machine learning algorithm. So depending on your business model, we have the ability to meet that complexity. So the first thing I want to do is, and also speak to kind of the features of G-SQL. I'm going to run this in 2 steps. I have a driver query. What my driver query is going to do is, hey, I'm going to output out a file, go look at all of my profiles. The first thing I do is delete everything that's in that same profile edge. And then I'm going to call this step 1 same profile subquery for every profile that I loop through. And so this driver query calls this second query. And so to run that, I run it, and the first thing it does is it prompts me for a threshold score that's based on my calculation. So anybody that has a threshold score of 0.6 or greater, I'm going to assume that they're the same person. Please understand, you can make those calculations your own and customize them. So I run this query. It's going to go through and delete them all. And then ones that says the same, they're going to insert some data into that same profile vertex. We can go validate that by looking at our load data tab. And it's going to show us how many people in that same profile vertex. And there's 3,301 people. Just for demonstration purposes, I'll run the query again. This time I'll set the threshold to be higher. I'll set it to be 0.7. And so somebody has to have, actually I'll set it to be 0.9. They have to have at least three attributes in common to be considered the same profile. This time I'm probably going to end up with about 150 people that I consider the same, or 833. So you can customize that logic. It's based on the components that you get as part of your graph, and things can, you can work it out that way. So we looked at use case 1, which is entity resolution. We looked at use case 2, which is customer experience or customer 360. Now we're going to look at what I call a standard report. I have sales data in here. So I want to go out here and go look at a sales report. One of the things that TigerGraph gives you the ability to is every query that gets compiled, and when we say compiled, is turned into C++ code that gives us performance, speed, and scale. They will get a RESTful endpoint API. So I can hit this API through something like Python, through a web app, through a BI tool, and I can run that query, and it's going to return the results to me. This query is essentially doing a group by that you would in Oracle or something else. We use accumulators, very similar to Spark or MapReduce. And we're saying group by the product category name, the sales date, summarize and accumulate the item quantity, summarize and accumulate the sales amount, and then I'm going to output that result. So I'll run that query, and it's going to give me a JSON output that looks just like something I would get if I was running on Oracle, Snowflake, Redshift, or whatever. Category name, sales date, item quantity, item sale. The only difference is the output for us is going to be in a JSON output. And then you can integrate that with the BI tools that will accept JSON, tools like Power BI and Click. So that's the third use case, to do a sales report. The fourth use case is I want to now start, just doing some basic customer experience stuff. I want to go out here and find the best customers. Simple algorithm. I'm going to go get all my customers. I'm going to sort them by their order amount and order count. And of course, the top one is going to be my best customer. So I run that query. It comes out and tells me that David Wilson is my best customer. He has 26 orders. He's bought 29 items and he spent over $7,700. This is something we do all the time in customer experience. And so now the next thing is I want to go find similar customers. This is my best customer. I want to go find people that look like him using a graph algorithm. So I have a query out here that's called similar profiles. You can execute this query. And to run this query, I say, I want to go look at the profile vertex. I want to give it that vertex ID. And I want to tell it to give me the top 10 people that look like David Wilson. I can execute that query. And almost immediately, it gives me those 10 people back. We can go through and do data validation, but I'll do a quick visual check. I'll do a view of these customers, take kind of a mental snapshot of the objects and the nodes that they have, the number of campaigns, the number of orders, the number of friends. And what you'll realize is that all the other customers look very similar. This is a graph algorithm. We're looking at the objects that they have in the graph database. This is where we get similarity. We didn't go through and say, are they the same age? Do they live in the same neighborhood? Do they drive the same car? We said, are there patterns for interacting with my company similar? And they begin to look very similar. And of course, you get JSON output with this, and then you also get a similarity score. Last but not least, what we want to be able to do is now do a product recommendation. We're going to look at a graph algorithm to go through and do product recommendations. In this example, I want to get fancy. PageRank is the algorithm that people have used for product recommendations, but they're doing it in most places just on the product description. I have a multi-step product recommendation. I want to go find people that are similar, and then I want to go look at the products that similar people bought, and then I want to make a recommendation based on it. And so that's what my product recommendation algorithm does. And so I give it a profile ID, and it says, here are the products that we recommend. And I'm recommending these products because these were like people that had products in common. So this is a customized product recommendation that's based on all of my experience management. I want someone that has responded to a campaign, that's responded to a support message, that's interacted with the chat. That's the people that I'm alike. Now go find the products that they have and recommend those. Okay, so that's enough for the demo. We're going to spend the last 30 minutes of this allowing you guys to walk through this exercise for yourself. At this point, what we need you to do is download a couple of solution files. I will place these files in the chat window, and you'll have the ability to go download them. You're going to download 2 files. I'll put them out there for you, and we will build our solution. The first file you're going to download is an export of this solution. I'm going to put it into the chat window. I'm not sure if you have it available to you. but you should be able to click this chat link. It's going to download a file from S3. That file is essentially a TigerGraph backup of this solution that I gave you a demo of. When you download that file, you're going to have to download it to your desktop, your laptop, Mac or Windows. It's going to go to that download location you choose. I am a Mac user, so I will show you how I do this in Mac. I hate to say that I am not. It's been such a long time since I've used Windows, I can't speak to how you do that, but on Mac, I'm going to execute a wget command. I'm doing it at the terminal session. I am in my downloads folder. So I'm going to do wget, and I'm going to copy in this export underscore cust exp 1202 tar.gz. And I'm going to download that to that location using wget. There are a couple ways to do it. This is the way I am doing it on Mac. So we'll give you about a minute or two to get this graph database export downloaded to your machine. Once you've done that, you can go into the blank solution that you created. I'm sorry, I did that too fast. Once your solution has been created and started, there are some icons on the left-hand side. The first icon that you can hover over and highlight is a icon that has applications. If you click on that, it'll give you a drop-down box. You have two options. You can click Graph Studio or you can click Net Data. Right here, click Graph Studio, and it's going to launch the Graph Studio application for that blank solution you created. Once you are there, at the main window on the right-hand side, second from the bottom, there is an orange link that says Import an Existing Solution. And this is where we're going to kind of walk through this together. So everyone should be at this point to where you are in your G-SQL application that you launched. You should be at the main menu page. You should have downloaded that tar.gz file. And now we're going to import that file into the solution we launched. So click Import an Existing Solution. Go to that download location and pick up that file you want to import. When you select that file, it's going to give you a warning that says import solution will erase all existing data, including all of your graphs. So be very important before you do that. So it's going to say, do you want to continue? Say overwrite, because that's what that import is going to do. Now it's going to import that solution. It is importing exactly what I just demoed to you. The graph schema, the mapping, the load rules, all of that good stuff. So while you're doing that, there was a question that says, is it possible to have a security wrapper around the RESTful API? Yes, it absolutely is possible. So we can secure that RESTful API. Even Graph Studio, everything can be secured. Also share that our graph database can be ran and fully secure and compliant. We do disk encryption, and we do encryption over the wire. So the whole application can be secured and ran that way. Graph Studio can also be integrated with LDAP, so we can support most enterprise security standards. There's another question that says, is it possible to import a solution without erasing previous graphs? Not through the GUI. So when you do it from the GUI, it's going to go through and do that. Um, and there's some things that we have in our roadmap to kind of address that. But there are, so right now there is not a way to do it without overwriting all of the solutions. So you do have to kind of be very careful with that. Okay. So after a couple minutes, your graph solution should have imported. The first thing we need to do is to, at this top global view, we need to choose the graph database. This speaks to our multi-graph solution. So within a single platform, you can have multiple graph databases. So choose the custom experience database, and you should, and then hit the design schema. You should see the exact schema that I was able to demo to you earlier. So that's the first part. The second part, we actually now need to import the data files. So the second file you need to get and download is a zip file that I'm going to place into the chat window. This is a zip file. It's going to get downloaded to your machine, and you're actually going to need to extract that and pick up the files. Once again, I'm on Mac, so mine may look different than yours, but essentially the command is going to be the same. I'm going to do a wget. I copy it and paste that file, and it's going to get downloaded to my downloads directory. Now I need to go into my file browser, find my downloaded file. Here's that file I downloaded. I'm going to move this one to trash because I have multiple copies of it. Now I need to expand this zip file. It's going to create that cust exp_data. And within there are roughly, I think there's 18 files. And we're going to upload these to our software as a service graph database. So to do that, I go to map data to graph. Here's a note. Since I imported this solution, it preserved my file names and the mappings. It's given a red warning because it doesn't see the data in this solution. So what I need to do is to add those files. So I click the white kind of file icon, which is the second on the menu bar, add data file. Then you click the green plus that says upload file to server. And I go to that location to where that file was, and I select all of them. It's 22 items and it's 25 megabytes of data, and I click open. So it's now uploading all of these files to the TigerGraph instance that's in the cloud. It's 25 mega data, so it may take a little time. Now that I've done that, you can see that all of the red warning dots have gone away. So I now have my files, I have the mappings, all of those things remain true. They were all part of my import. Now I just needed to add the data to this server as well. This is a way where we move solutions. So one of the best models of working with TigerGraph is you may use our Docker image to do development. You may do something on an EC2 instance for the development. Now we're going to move it to the managed service solution. It's running in production. All I need to do is upload my solution there. Okay, I'll pause and see if everybody's at the same place. You should be in your solution that you launched. You should have imported an existing solution. Then we downloaded the data files, and you should have added those data files to your solution. The next step is we need to go through and actually load the data. So click the Load Data tab on the left. If you can see on the right-hand side, it's giving you a count for all your vertexes and edges. Everything should be 0. And we can begin this load by clicking the Start Loading button on the top left. Okay, to do the import solution, when you go into Graph Studio or to tgcloud.io, right click on your solution name, select Graph Studio. That's going to bring you to a starter screen. And if you need to get there again, you can click that Graph Studio icon. And in the pane, there are several options. Click the Import an Existing Solution option. And then you need to pick up that cust exp underscore export. Let me get the right name. Export underscore cust exp 1202.tar.gz. Select that file, and that's going to import your solution. Okay. I'll go back to the data loading. I loaded my file. It's giving you a status of where you are on loading the files. On the right-hand side, it's giving you some trends of how many, what the loading speed is. So for our edges, we're loading about 300,000 messages a second. For the vertexes, it's about 47,000. All of that, of course, is scalable and contingent on the size of the instance. This free instance has 4 gig of memory and 50 gig hard drive. So the performance is not going to be something you want to write home about, but it's still very good. So I now finished my load. This sample database is based on about 10,000 customers. So we have posts, products, profiles, their addresses, emails, all those different things. Yes, and so there's a question that says if you have to start from scratch into where there no mappings exist, I'll actually show that to you right now. So I'll create a mapping. So I'll add a data file, or I'll pick a file that already exists. So I'll pick my profile and I'll load it to customer. So I select the file that I want to load. Let me back up a minute. I'm going to give you guys a quick sample of how you would do a mapping if it doesn't exist. You pick the particular file that you want to map. In this instance, I'm picking that profile.csv. Now I go up to the top. There, the third icon says map data to file. So I click that button, and then I tell it what I want to map it to. Hold on. And so I clicked that file. I clicked on the customer icon, and it gives me an orange bar. On the right-hand side, it's going to list all the attributes of that incoming file, and then all the attributes on the customer vertex. And to map them, I just do the point and click method. I click the profile, I map it to the profile ID. If I pick the source, I'll say data source can go to first source. I can pick that date and go to first source date. The other components aren't there because in my sample, this is going to be calculations and aggregations of what a customer has done. The number of months they've been a customer, their status, the number of promotions, the number of orders they had, their average sentiment. So I can't map this input in from the endpoints part. But I wanted to show you how you can just go through and map components. If I don't like that, I can click that map and click delete, and that mapping's gone. Yeah. Okay. We're going to do a quick review of how to load the files from the CSV file. So we downloaded the .zip file from S3. For me, I did a wget and I pasted in that file name, and that's going to download it to to my local laptop. The second intermediary step you need to do is to take that file and uncompress it. And it's going to compress to a folder called custexp_data. And I got a second one because I did it twice. If you expand that, there's 22 CSV files in there. Now, when you go into Graph Studio, go to Map Data to Graph. At this point, you should see all those files, but there's probably a red dot saying warning. I don't see them. The second icon says Add Data File. Then click the green button that says Upload File to Servers. Point it to that location to where you unzip the data and select them all at one time. And then click Open. I'm not going to do it here because I've already done it. But once you do that, that's all you need to do. So you can cancel out because all the mappings are there. And then once you do that, oh, I did forget, it should say you need to publish your mapping. So you may need to go out there and click Publish Data Mappings once you added that file. I'll do that now. I shouldn't have any changes, but I'll do it just to show you how it does it. Then you can go to the Load Data tab. There was a question there that says, if there were 10,000 customers, does it auto create 10,000 vertexes? Yes, it will create those. TigerGraph is a label property graph. The way we store our graph is exactly as it looks in this schema. We don't have a two-tiered storage mechanism. Other graph vendors will store the data in a key value store or something like Postgres, and they'll create the graph in memory. The way you visually see this graph is the way that we store. So as I load these profiles, there's 10,000 out there. We're going to create 10,000 vertexes or nodes to go with that. Okay. We're running short on time. We want to get through these questions. We're going to walk through these use cases. Everyone should have their graph database set up. Everybody should have been able to import a solution. At this point, you should have loaded data to that solution. You should have counts on your vertex and edges. Now we want to go through and do Explore Graph. So on your Explore Graph pane, we're going to just manually do the Customer 360 view. When you first come into the Explore Graph, everything is going to be selected. What we need you to do is just to uncheck all of these by clicking the All button, clear that out, and then just manually select Profile. Just for purposes, change that 5 to 8. And we're going to tell it, go out and get 8 random profile vertices. You get those 8. And then just for understanding purposes, traverse into a couple of these vertexes. If you need resize it, you can resize it manually. I have a mouse that I right click, or you can use the buttons on the left to increase or decrease the way you're sizing. You can traverse into these. So that's the customer 360 use case. We're doing it manually because I wanted to do that educationally manually. You can do this whole customer 360 through GSQL or programmatic way. The thing is, customer 360 is very visual, so we did it in a visual way. So that's the first use case. The second use case we're going to do is we're going to go in and we're going to walk you through creating your own entity resolution. So click on the Write Queries tab. You should have a list of GSQL queries. Find the one that says step 1 _ same profile. Click on that query. On the right-hand side, you should get this query. Just for workshop purposes, we're going to change the score that we're calculating. So for if they have the same profile, I want you to change, if they have the same phone number, I want you to change that to 0.4. If they have the same email, leave that 0.3. They have the same IP address, change that to 0.2. And for the same address, change that to 0.5. So you should be able to be at the Write Queries tab. You have selected the step 1 same profile query. And we will go through and update that. We have someone that's trying to kind of go through the load data part. I'll go back and go over that. And again, let me get people to the point where they can compile this query. Then we will review that portion as well. So in your step 1 same profile query, we just customized the logic. And we said, if the profile phone is the same, just change that number to 0.4. If the profile IP address is the same, change that to 0.2. And the profile address is the same, change that to 0.5. Really what we're saying is, hey, if someone has the same address, they live in the same spot, they have the same phone number, chances are they're the same person. We can still go through and do the fuzzy matching on their first name and last name. We're looking at the objects that are entity objects. Now what you need to do is save this query. I need to save this query. There's a disk icon on the top menu bar. Click Save. Now you also need to compile the query as well. So there is a up arrow that says Install Query. So we need to install this query. So click that. This will take roughly 2 minutes. It's taking this GSQL and it's going to turn it into C++ code. It's smart enough to know that these two queries are connected. So if I compiled one, we need to compile the other. So now click Install. So while this query is installing, I'm going to go through and review the data uploading part. So step number 1 of data uploading is you need to do a wget of the zip file that I placed in the chat menu. That zip file is coming from S3. It's going to have an S3 bucket, but the last part of that bucket name is custexp_data.zip. When you do that wget, it's going to download it to whatever location you chose. For me, I downloaded it to my downloads folder on my Mac. The first thing I need to do is to actually now uncompress that. So I go to my downloads folder. Here is that zip file. I'm just going to double click it to uncompress it. Let me clean up after myself first. I'm going to double click that to uncompress it. And it's going to open up a folder called custexp_data. Within that folder are 22 CSV files. In Graph Studio, click on the map data to graph. On the top menu banner, click that second icon which says add data file. From there, at the bottom of that pop-up menu, there's a green plus button. And now you click that green plus button and you go to the location to where you downloaded those files. Mine is in downloads, custexp_data, and now select all of those files. So what I do is select the top one, I scroll down, I hit shift, I hit the bottom one, and then click open. Once you do that, all you have to do is click cancel, and now all of your data files should be loaded. The red warning should have went away. You need to hit that top button which says publish data mapping. Then go to the load data tab. And when everything comes up, you'll have that play button and you can reload it. Okay, we're gonna go back to the query we wrote. That was just a rehearsal of in loading the data. We're gonna go back to the query we wrote. Everybody should have compiled their query. Now we want to be able to execute this query. So review of where we are. We're basically allowing you to customize your own entity resolution algorithm. We changed the coefficients, if you will. Phone is now 0.4, email is 0.3, IP address is 0.2, a physical address is 0.5. So if you got all of them, you would have a score of 1.4. Now select the step 1 entity resolution query. This is our driver query, and we're going to execute our entity resolution use case by clicking the white play button which says run query. It's going to prompt you for a parameter. That parameter is going to be the threshold that says if someone has this score, we consider them to be the same entity resolution. We changed our thresholds, and so now I'm going to say a person has to have a score of 1.0. Then you can run that query. I didn't really output anything because this is more of an ETL step. I inserted edges. This shows that TigerGraph is an ACID compliant database. So you can do the ELT method. You can extract low data into TigerGraph, do some transformations, and create other objects. To confirm that, we can go to the load data tab just to look at our vertex and edge counts. And there's an edge that we inserted into called same profile, and we inserted 487 entries into that same profile type. The URL for this is tgcloud.io. The starter kit we chose was the blank starter kit. Okay, so we're done entity resolution. This is important because entity resolution is part of customer experience, but in some cases, entity resolution is a use case that kind of stands on itself. We're going to go through the next query we ran, and I'm just going to show you how to execute some of these queries. So the next query we want to run is step 2 sales report. This is an example of running just a standard kind of SQL style aggregation analytical query, something that you would do in something like Redshift or Snowflake. Uh, this is really meant to demonstrate that we can do the same thing in TigerGraph. Even though it's a graph database, we still carry on those traditional relational database concepts. The G-SQL is going to look a little different because we're traversal based, but we can do all those. So to run this, just hit the run button. It's going to output JSON. That's going to basically be the store sales, a category sales report. It's just going to give you a JSON output that has category name, sales date, item quantity, and sales quantity. There was a question earlier about can we do this in Tableau or something like Click. We, by nature, output JSON data. So any BI tool that can import JSON data can pick this up and leverage it. I know of two, Power BI and Click. I'm not an expert on Tableau or something like that, so I'm not sure if they just have a JSON importer, but we can make it CSV. Some of these graph tools are beginning to have graph visualization components to them. Some do not, but there are a whole bunch of graph visualization tools that you can get on the market. Some of them are open source, some of them are actually paid licensed products, but there's a whole style of visualization to support the graph data. We do that in our Explore Graph model, but sometimes there's additional needs to do that embedded or part of some other application. And once again, if you have additional questions to that, hit our website, hit that to contact me button, and we can get somebody to kind of have a meeting with you to walk you through those questions. Okay, we have about 7 minutes left. I want to just kind of put some things in your hands so you can see everything else. So that was the step 2 store sales report. Step 3, we want to just go run a query to find out our best customers. Your data should be the same as mine. This query is going through and it's looking at the customers and their orders. It's going to calculate the number of orders they bought, the order quantity, the sales amount. Now I'm going to go through and find the 100 best customers, and I'm going to sort them by the order count and descending, and that's going to give me my best customer. So to run that, hit that play button. And once again, it's going to give you some JSON output, and it's going to list out the 100 best customers. For us, it's David Wilson. I'll go through and pick up some random person, say Lindsay Moore. Her profile ID is 3674. And now I want to go find similar people. So the next step is to go to this query called SIM_similar profiles. I named it that way because we're running a similarity algorithm. This is a graph algorithm that's calculating a similarity score. To run that, I hit the run query in interpreted mode. It's going to prompt me, change the vertex type to profile, put in the vertex ID that you're looking for. I picked up one from my output, 3674. And then the top case says how many similar people you want to find. And I'll say find the top 25 similar people and hit run. And I actually got a divide by 0 error because that person didn't have anybody. So I'll change it to this and say vertex 6739. And I get the top 25 people that are similar. You can go in and traverse these people and look at them and kind of validate that they actually are similar from a graph database perspective. And then once again, as you begin to traverse these people, you'll see that they have connections in common and things of that nature, which you should be expected because they're similar. The last query we're going to run is we're going to take that same person and we're going to run a product recommendation. This is also a graph algorithm. Run that recommended product. It's looking for a vertex type of profile. I entered a profile ID of 4543. That's what's in the comments in the query. And it's going to give me the products that it recommends. Last but not least, I'll point you to our GitHub site. We have a list of graph algorithms. All of them are open, available. You can test these out in your TG Cloud instance, but there are about 9 different graph algorithms that we provide, from betweenness to connected components, cosine similarity, estimated diameter, Jacquard similarity, um, shortest path, page rank. All of these algorithms are open, available, and free, and they are all customizable. This is one of the biggest differentiators between us and other graph databases, is that our algorithms are open. They're not black box. We push them out as G-SQL, so you can install them, run them on your graph database. You can update them and customize them to add whatever filters, condition you like, but still have the heart of that graph database, that graph algorithm available to you. Last but not least, we're going to spend a few minutes kind of talking about the importance of customer experience trends. Essentially, um, market research shows that being able to capitalize on customer experience is one of the most exciting business opportunities out there. Most consumers will tell you that they are more likely to interact and purchase from companies that take customer experience seriously, that know them, their preferences, and their behaviors. Um, Customer experience is about that journey. The objective is to put algorithms, connectivity, and all these analytical techniques in place to figure out how you mature someone from one point in the sales cycle, sales funnel, as the next. So how do I take all my people that have visited my website and move them to the point to where they're doing discovery? They move them to the point to where they're choosing which product they want, and then to ultimately get them to purchase something. All these become patterns that you can detect inside of your graph database with our graph algorithms. And you can leverage things like, what is a person's preferences? How do you know which channels they want to look at? You get all that learning and understanding from things that you picked up in the graph. We do have visualization toolkits that we can work with. Most of our customers that are doing customer experience, they're doing a visualization toolkit around customer journey. And it's a toolkit that allows you to look at how your customers are interacting with you over their journey, and then very quickly go find similar people and do similar things. Um, all of those things are available, and some things we can actually help you with. The last thing what I'll do is kind of tell you that all of this is based and made available in part because of the capabilities that TigerGraph provides as a graph database. We're scalable to billions of data sets. It is a mutable graph to where we can do inserts, updates, and deletes. We have real-time performance. Our MPP property graph allows you to do deep link multi-hop analytics, 10, 15, 20 links deep. And of course, Graph Studio is very simple development activity. In summary, what you get from TigerGraph is a collection of multiple things. We are what I call the bridge to machine learning and AI. we are three components: a distributed graph database that gives you the ability to do advanced analytics that you would get from a relational database, plus the ability to do graph algorithms and augmented machine learning with our algorithms within database machine learning. What this really brings value to is we are ultimately real-time decisioning. We can run a graph query that runs an algorithm and pushes out a decision, which is a score, a recommendation, or a similarity, do that in real time. Our most successful companies are not only using this for BI and analytics, but they are integrating these decisions into their operational activities. That is gets us to the point where we've exhausted our time today. After this session is over, we will email you a link of the video. You will get a list of a link with this presentation that you can use to walk you through the exercises. You have the data files and the import. So at some point in time, you can do this for yourself on TG Cloud. And once again, if you have questions, reach out to us on our website and we'll have somebody reach out to you. Thank you for your time. Avi, I think that's it.
Great. Thank you very much, Stephen. Thank you, everybody, for joining us. And as Stephen said, you can expect an email from us in 24 hours detailing all the information. Here's the email address for Stephen. There were a couple of questions regarding POCs, so we will follow up on that. Thank you very much for joining us today.